Morning, everyone. How are you guys doing today? It's so nice to see the class is full. I rarely see the class is full. Thank you so much for being here, everyone. A reminder, our fourth exam is exactly 1 week from today, next week, Friday. Based on the materials on Tuesday, whatever materials, up to whatever materials we cover on Tuesday, we'll decide what the exam will be based on what, from what to what. So I posted the review sheet based on 7.4, I think. From 7.4 to 10.3. If I'm not wrong, let me just check real quick. Yeah, our review sheet, which I posted, is based on 7.3 to 10.4. But let's see how much we finish by Tuesday. Probably we'll be able to finish everything by Tuesday. And then on Thursday, if we are finished with everything on Tuesday, then probably on Thursday we'll do a little review. And this time I'm planning to do review a little differently. I will tell you what will be in the exam, but you're going to work in class on the questions you need help with by yourself or with your neighbors. That's my plan. Any question? Comments? Concern? Simplify. I should only say simplify. I don't need the factoring. Okay, do you remember what we did yesterday? Do you remember? We simplified radical. And when we simplify radical, let's see, this is 5, so that we have the same number. The difference between A and B is that A has a square root, but B has a cube root. Based on what type of index you have, what type of radical you have, you look for different things. When you have square root, what do you look for? A number how many times? Twice. And when you work with cube root, you look for a number how many times? 3 times. Same thing for variable, we look for the multiples of 2. And for cube root, we look for the multiples of 3. So step 1, we break down our radical into 2 pieces. One is for the number, one is for the variable. And then we reduce them. 54 is what to number? 9 and 6. Do we see the same number twice? We don't, but we still know 9 is square root of 3. Sorry, square root of 9 is 3, right? So since we're dealing with square root, maybe we can stop here because we know what is square root of 9. What is square root of 9? 3. So even though you don't see the same thing twice, but you do know square root of 9 give us the result 3. Do we know what is square root of 6? No. Square root of 4 is 6. So square root of 4 is 2. Square root of 6 is not a real number. So is it a perfect number? It's a decimal. We don't know. So we'll leave it alone. For variable, square root means our denominator is what if you convert into exponents? Square root of x is x to the what power? 1/2. So denominator is 2. So we want to see, can you divide 5 by 2? Here, this is same as 5/2. Can you divide 5 by 2 evenly? That means you have to split our square root into 2 pieces. x squared, but do you have anything bigger than x squared in 5? What number is smaller than 5 but divisible by 2? 4. So x to the 4 and x to the 1. Now 4 divided by 2. From here, what do you get? 2 of them. And this is not reducible, so we bring it down. Do you remember what do you do next? So this is free, they don't have any house, so they're free. We put them together next to one another. And there are 2 underage who live inside their house. So we put them together inside one house. And then we are finally done. Any question? We do the same thing, but this time we are looking for cube root. So let me change the color from black to blue. This one. Cube root of 54 and cube root of x to the 5. We want to see same number 3 times. So you said when you say 54, which 2 numbers comes in your mind? 9 and 6. But you don't see the cube root of any of these, so you break them more. What is 9? 3, 3, and 6? 3, 2. So we need 2 houses. How many we put together? 3 of them. We are looking for same number 3 times. So we put same 3 times. That means what we did not use? The 2. So it lives separately inside another house. What happens to the cube root and cube power? Cancel. And we left with a free 3 and a cube root of 2. This time we break down x to the 5 into which 2 pieces? X to the what and x to the what? If you do x to the 4 and x to the 1, is 4 divisible by 3? You're looking for a number that is divisible by 3 but smaller than 5. 3. So one of them must be x to the 3. Then how many of them we have under another root? 2 of them, x squared. And since we have the same radical and root, we can cancel them. We get x without any exponents. And this is not free, so it comes down. So our free things are 3 and x. We put 3 and x together. Our underage who cannot leave the house is 2 and x squared. So we put them together inside the house. Bless you. Same question, but based on our radical, we get 2 different results. Any question? Which exponent? I forgot. Thank you. Done. What are you looking for in the next question? How many times? 4 times. But this time they have a multiplication between them. So we are going to have what? We are going to have 2 radicals. One is multiplying the numbers and another is multiplying the variables. So our numbers are 2 times 8 and our variables are x times x to the 7. So 2 is 1 and 2. 8 is what? 2 times 4. Do you see the same number 4 times? So I need to break this down more. 2 and 2. So there is no more 4 times into 2 and 2. Now do you see the same thing 4 times? Which number? 2. So we have 4th root of 2, 4 of them. Do we have anything extra? Any number extra? 1. But any radical of 1 is 1, right? So you don't have to write it down. If your factor is 1, ignore that. Besides 1, if you have anything else, you must consider that. Fourth root and fourth power. Fourth root and fourth power, just the 2. And no number extra. Now in multiplication, what do we do with the powers? Add them. So how many x we have now? 8 of them. Is 8 divisible by 4? That means you don't have to split. It's simply 8 divided by 4, which is 2. Both of them are free. So we put them together as free factors. So sometimes we don't have anything left over. We don't have anything extra. And sometimes we do. The left page has something extra after you split them. But the right page, they all are perfect. Any question? No, because 1 with any power is 1. Remember the exponent rule? 1 with anything, positive, negative, exponent, fraction. 1 with anything, any power is always 1. You must consider that, like the 2. In the left page, we used three threes, but we did not use the 2, so we had to bring it down. Okay, try this by yourself. This is one of my favorites. And then I have one more. And then we have something different. So try this too by yourself. I mean, you don't have to do by yourself, with your neighbors. It doesn't matter how many variables you have the same rule. You need to simplify each one of them. So based on how many different things you have, you're going to break down your radical that many times. And then simplify each one of them. And for the right one, we can combine the two radicals into one radical because we have a radical rule. And then just like before, don't do anything until you convert all the negative into positive. That's interesting. Four, four. Oh, Eliza is missing today. Fabricio, Sergio, here. Miley, here. Oliver, here. Himadri, here. Mustafa, here. Jacqueline, here. Jiain, here. Anaya, here. Atsiri, here. Jason, here. Joseph, not here. Sitlali, here. Saida, here. Mohammed, disappeared again. Ronaldo, here. Daniel, here. Jeremiah, here. Camila, and Philia. So Mohammed and Eliza, two are missing. And the one is defined, but the ones that make it possible. You get bullish, but so not a chill. The chill really has which is like another property. None of them are public square. Public square. Good. So you see 4 and you see 2. So when they cancel out, there is no more radical. It's only 2 without radical. That's what I'm saying. So 2 doesn't have any radical because it cancels the radical. So why 2 still has a radical? The last line. Ask that 2, why 2 is a radical? It's only 2, but why 2 is a radical? And what is square root of 4? So, we have yeah. But if the biggest number is more than and no, it's very one time. One times two for eight. And then times two. And then yeah, all of that. It's three ways to the board. And so then that's 3,000 where you see it. You know, but you don't usually do it. Simple. But then like I don't or it wasn't. Right. Don't tell me to right. And so the police to write but it's quite excellent. Right. Say that together. We break down each one of them separately. And then we look for same number twice. So if you can see 48 actually 16 times 2, 16 times 3, and 16 is the perfect square number. But if you can't see it, no problem. You do 8 and 6, right? 6 times 8 is 48. But none of them are perfect square number. That means you cannot stop. You have to go further. 6 is 3 times 2, and 8 is 4 times 2. And if you want to stop here, you can. But if you want to keep going, then you can break this down and get 2 more. Now you're looking for same number twice. We have this twice and we have this twice. That means we have same thing twice. So we do square root of 3, and then we have 2 square twice. The square root and square cancel out. So from here we get only the base 2, but they're multiplying, so we get 4. And this radical 3 is not free, so we just bring it down. If you want, you can write the 4 first and then radical 3, but this is not wrong. In multiplication, you can switch around their position. So this is what we have from the number. 4 is free, but 3 is not free. So you go to the variable. 5 is not divisible by 2, so we split that into 2 pieces. One number must be divisible by 2. So how can you split your 5? Which 2 numbers? 4 and 1. You can do 2 and 3, but 2 is not the highest one. You're looking for the highest number smaller than 4 that is divisible by 2. Now here you divide 4 by 2, you get square, and this is not divisible by 2, so it stays inside. So this is our free one. Then you go to y. 9 is not divisible by 2, that means you have to split our radical into 2 pieces. How many of them goes under one radical? 8 of them. And we have one of them single. So 8 divided by 2, from here we get 4 of them. But this is not divisible by 2, so it stays same. And 1 power, you can make it invisible. Lastly, z is 3 divisible by 2. That means you have to split our z into 2 pieces. How many z goes inside one radical? 2 of them. That means we have 1 of them alone. Now here, the square root and square power, they're the same thing, cancel out. We left with a single z, and this is not divisible, so we get a radical z. So this is free and this is free. So we have free from each one of them. We put them together. 4x squared y to the 4z. All of them are free. And then there are few things like the 3 is not free, x, y, z, none of them are free. So you put them together under one radical, 3x, y, z. And now we are done. We have all the free together, all the non-free together, and they all are playing with one another. Any question? In the next one, if you try to simplify fast, you can, but then your life will be harder. So instead of simplify individually, first make them into one radical. And we are allowed to do so because of the radical rules, the exponent rules. It is if you have the same radical in the numerator and denominator, you can combine them. Or if you have the same radical and numerator denominator, you can also split them. So here we have the splitted version. we need to combine them so that you can simplify the inside first. In other words, don't do anything until you have your numerator and denominator together. And we are allowed to do so because we have the same radical, same index. As long as you have the same index, you can combine them, you can split them. So 3 goes to 81, how many times? Can you divide 81 by 3? 3 times what number is 81? 27. Now we have a problem. Our 10 is a negative on the top and 7 is a negative on the bottom. Remember I said before, don't combine them until you convert all the negative power into positive power. Yes, you can combine them, but I don't want you to make mistake. So before combining, make them positive by switching the position. So we get cube root of 27. There is no more x to the 10. We have y squared. From the denominator, now we get a new one, y to the 7. There is no more 3 on the denominator because we canceled it. We have x to the 5. But now the x to the negative 10 comes down and turns into a positive 10. And now we can complete them, combine them. What do we do in multiplication? Do you add, subtract, multiply, divide? Which one we do to the power? Add the powers. So how many y's we have? 9 of them. And how many x we have? 15 of them. Just like the multiplication, we also split our radical now. Cube root of 27, cube root of y to the 9, and cube root of x to the 15. It doesn't matter whether they are multiplying or dividing, you can always split them. Now, do we know what is cube root of 27? Like in 27, can you write 27 with some number 3 times? 3. So cube root of 27 is cube root of 3 cube. Can we divide 9 by 3? Can we? How many times? 3. Can we divide 15 by 3 evenly? How many times? 5. So the cube root, cube power cancel out. For number, we get the 3. And what is the power for y now? Y to the 3 and x to the 5. So this one doesn't have any remainder. In the exam, I'm not going to give you the division, but your homework and quiz has division. Any question? Go ahead. So y square was already given positive, so we have a y square. But denominator is a negative. That means we need to bring the denominator y into numerator. So denominator comes into numerator comes into positive 7 instead of negative 7. Let me actually see so you can see. So whatever switched the position, I wrote them with red so you can see they didn't belong there at the beginning, but we put them there at the end. And now something different. We are looking for square root of a polynomial. Now, square root of a number we know how to find, square root of a variable we know how to find, but square root of a polynomial we don't know how to find. So anytime you see any type of polynomial, you should always think whether it is factorable or not. Can we factor x square minus 10x plus 25? Two numbers multiplied to 25 combined to 10. Minus 5, minus 5. That means we have the exact same thing twice. So we have square root of x minus 5 squared. Oh, we have the radical and square the power, same thing. So we can cancel them. Because they're the same, they're the opposite of one another. And we're left with this inside. But since square root is an even power, even radical, so there is a condition. The x minus 5 cannot be negative. Because if you have a negative inside the radical square root, it doesn't exist. That's why whatever we have for x minus 5, we don't know what is x, but whatever that is, the whole quantity can never be negative. So in order to indicate that, we use a symbol absolute value. Absolute value means whatever we get from here, it must be positive or zero. It can never be negative. So instead of just having x minus 5, we have x minus 5 as a positive solution. And we do that because we don't know what is x. But for other numbers, we didn't have to do that. See here, when it cancels, there's 3. Before, when it did square root, let's see here, square root of 2 we cancel and we wrote 2, not absolute 2. Because we do know that our 2 is a positive number here. But for x, we had no idea what is x. So that's why this expression, this must be positive. Otherwise, if it turns into something negative, it becomes invalid. Eliza, you are here. I marked your absence. Okay, the next concept is totally different than what we did so far. It's called distance. Distance between 2 points. How do we find them? You have two choices. Either memorize the formula or derive the formula if you forget. If you want to derive the formula, there is a way of doing it. Let's say you have a point x1, y1 here, and you have another point x2, y2 there. We want to see how much is the distance, the direct distance from these 2 points. Now, mathematician says, well, we actually don't know how to find this the direct distance, but we can use a method. We can see how much is the distance. So this is x2, this is x1, and this point gives us y1. So this is 0. So this is y1 and this is y2. This point is x1 and this point is x2. So that's it. Well, let's see how much distance we have horizontally between x1 and x2 and how much distance we have. Let me change the color. Vertically from y1 and y2. So y2 minus y1, x2 minus x1. Sorry, x2 minus x1, not y1. x2 minus x1. So how much distance is between x2 and x1? How much distance is between y2 and y1? Let's see how much we have them. If you know this distance, then what this become now? A right triangle, right? And when you say right triangle, what comes in your mind? There's a formula, right? Anytime you see any right triangle, there's a formula comes in your mind. Do you remember which formula? Yep. So Pythagorean says we have a square. Let's see, this is a square, this is b square, this is c square. So this is a, so in my bed. Let me change the color. So if we have a triangle, A, B, no, let's say this way, A, B, and C, then we have C square equals A square plus B square. In other words, this distance, let's say this is D. So this distance square is same as A, which is this distance. What color is it? X2 minus X1 square. And then we take the distance of the Y. So Y2 minus Y1 square. So distance square is this square plus this square. This is X2 minus X1. This is Y2 minus Y1. So you're looking for D, not D square. So in order to get the D, we square root both sides. The square root and square power cancel out. Square root. We get the D alone, and this becomes X2 minus X1 square plus Y2 minus Y1 square under the square root. And this is the distance formula. X2 minus X1 or X1 minus X2, it doesn't matter, because when you square them, the difference automatically becomes positive. So either you memorize the formula or you derive the formula. It's up to you. Now, once you know your formula, you go ahead and apply that to find out distance between any 2 points. So you're looking for what's the distance between -5, 3 and 2, -3. So this is our x1, y1. This is our x2, y2. You can switch the position. It doesn't matter. So you start by the formula. The formula says x2 minus x1 square, y2 minus y1 square, and then take the square root. Or the other way around, but it doesn't matter. What is our x2? How much is it? x2, 2. And you're subtracting x1. What is x1? -5. So we get double negative here. What is our y2? And you're subtracting y1, 3. The double negative turns into positive. So what do you have in the first parenthesis? 7. So 7 squared. And what is -3 minus 3? -6 squared. You cannot cancel the radical with the power because we have a relation here. In a relationship, the radicals and power cannot cancel out. Only in multiplication they cancel out, not in addition or subtraction. That means we have to write them down. How much are they? What is -6 squared? +36. And then you add them. 49 plus 36. 85. can we split 85 into two pieces? One is divisible by 2. Like, can you divide 85 by any perfect square number? A perfect square number is 4. 2 square is 4, 3 square is 9, 4 square is 16, 5 square 25, 6 square 36, 7 square 49, 8 square 64, 9 square 81. Is 85 is divisible by any of these? Nope. It's definitely not divisible by 4, not 9, not 16, not 25, not 36, definitely not by 49. Since we cannot divide 85 by any of these, we have to stop. There is nothing much you can do now. There will be one question in the exam about distance. First, you have to write down the formula. So what is the distance formula? You'll get point for that. And then there will be an example. Apply this formula to find the distance between these 2 points. Any question? Daniel. Well, the formula is the formula, but I derived. So when I derived, when you find the distance, so it's bigger number minus 1. Right? So x2 minus x1. Yes. Since I derived it, so it's x2 minus x. But if you don't want to derive, just memorize the formula. And x2 minus x1 or x1 minus x2, it doesn't matter. Why not? Because of the square. Whatever result you get, and then when you square that, everything becomes positive. The next new thing is midpoint. So there will be one question, what is the formula of the midpoint? And there is one question, apply the midpoint formula to find the midpoint between 2 points. Now midpoint means what? Middle point. So you have 2 points, let's say one is here, one is there. You want to know what point we have exactly in the middle. So what mathematician says, well, it's easy. All you have to do is see what is the middle point of your axis and what is the middle point of your y's. Whatever is the middle point for x and middle point y, that will give you the middle point of the line. That's why what we do is we take the middle point of the axis, middle point of the y's. How to find the middle point? We add the 2 numbers and divide by 2. That's how you find middle. So take the average of the x values, take the average of the y values, and that's it. That's your middle point. x1, y1, x2, y2. So our midpoint is the average of the axis. So you're going to add the 2 x values. So -5 plus 2, you take the middle of that. Now your y is 3, another y is -3. You add them, you take the half of it, the middle. What is -5 plus 2? -3. And what is 3 minus 3? 0. Now, what is half of -3? -0.5. 1.5. And what is half of 0? Still 0. So the middle point between these 2 points is x value -1.5, y value 0. And if you want to see that, let me actually show you here. On -5 and to -3. So let me go a little bit down. 1, 2, 3, 4, 5. 1, 2, 3. There is 1 point here. Another point is 2, 1, 2, and then 1, 2, 3 here. Now, can I draw? Ruler. Oh, maybe the one was there. Oh, my ruler doesn't work when I want it to work. Okay, ruler. Ah, my ruler doesn't work. Okay, no problem. Let me try doing it here. So if you draw the line between them, this one here, -1.50, is exactly the middle between these 2 points. So this is what we did. This is our middle point here. So it took the half of the x values and it took the half of the y values, and you got the result. Any questions? Exam. No, I'm just showing you the graph to visualize what we did. No graph is needed. No deriving is needed. If you memorize the formula, you're safe. But memorize the formula correctly. Any question? No, you can keep it. I simplify it with a small number, so you know how to do that. Let's see, have 37/5. You have no idea what that is. Leave it alone. So with this, you are done in section 10.1, 10.3. That means you must do homework, whether I assign them or not, by next Tuesday, 10.1, 10.3. And also their quizzes. I think they're one quiz. And now we are going to add and subtract radical. When you add and subtract radical, there are two conditions. We have to have the same type of radical, like same index. Also, we have to have the same radicand. So this is index, whatever we have inside the radical sign, and our radicand is whatever we have inside the radical sign. So if you don't have one of them not same, you cannot combine them. In order to combine, they all have to have the same radical symbol and same radicand inside. This is what I have written here. As long as you have the same radical with the same radicand, then you add or subtract their coefficients. What does that mean? Let's say you have, example, let's say you have 5 square root of x and you're subtracting 3 square root of x. You see, we have the same radical, square root. Also, we have the same radicand, x. As long as you have the same type of radical and same radicand, then you add or subtract their coefficients. So this coefficient is 5, this coefficient is -3. How much is 5 minus 3? 2. So answer is 2 with the radical of x. So treat your radical as a variable, and then you add or subtract their coefficients. For example, this is same as if I have given you 5y minus 3y. So we know the answer, it's 2y. So think your radical as a variable. If you think your radical as a variable, So in order to add or subtract radical to the same radical, sorry, same variable. So when you have the same variable, we add or subtract the coefficients, but leave the variable alone. We do the same thing for radical. Okay. If you don't have at least one of them that's same, you can't do that. For example, let me write this down here. Let's say you have 5 square root of x minus 3/4 root of x. Do you have the same radical index? Since they are not same, so it's not combinable. Cannot combine. Something is not same, you cannot combine. In order to combine, two things must be same. Same radical, same radicand. Sometimes we see things, they look different at the first glance. But when you simplify, they turn out to be the same thing. For example, in the first example, they said add square root of 20 with 2 times square root of 45. Even though you have the same radical, square root, but you don't have the same radicand, right? One of them is 20, the other is 45. So maybe you think, oh, they're different, so you cannot combine them. Well, they're different, true, but can I simplify them? Now 20, can you divide 20 by any perfect square number? By 4. So we can split 20 into 4 and 5. So square root of 4 is square root of 5. Square root of 4 gives us 2, and we have no idea what is square root of 5. So we could simplify square root of 20 into 2 times square root of 5. Now similarly, 45 is not a perfect square number, but can you divide 45 by a perfect square number? By 9. So we split our 45 into 2 pieces, 9 and 5. We get square root of 9 and square root of 5. We know square root of 9 is 3, and we have no idea what is square root of 5. Now, the second term is the coefficient, so we need to multiply the coefficient with whatever we got after simplifying the 45. At the end, we got 2 square root of 5 from 20 and 6 square root of 5 from the second term. And now if you compare them, do you have the same radicand also, same inside? Yes, we do. That means we can combine their coefficients. We have 2 and we have plus 6, so we have 8 of them. 8 square root of 5. It doesn't matter what type of radical we have, the rules are same. This example is a cube root. That means you're looking for a perfect cube number. Now, even though all these radicals, they have a perfect cube, cube root, but look at the inside. None of them are same. So you may think they are not combinable, but actually they are if you simplify them. So 54, we did it before, cube root of 54, you split them into 9 and 6, you split 9 into 2 pieces, 6 into 3 pieces, and then you see 3 times. So you get cube root of 27 and cube root of 2. Cube root of 27 gives you 3. What is cube root of 2? We have 10. 16 is not a perfect cube number. But when you split them, we get 4 times 4. And if you split 4 more, we get 2, 2, 2, 2. So we see 2 3 times and a single 2. So 2 3 times gives us 8. A single 2 is a single 2. So this gives us a 2 and square cube root of 2 and 1 down. Now second term is a coefficient. That means after we simplify, we need to multiply the coefficient with the result. So that turns out to be 10 cube root of 2. Lastly, we have cube root of 2. It's not simplificable, so you just bring it down Now, once we simplify all of them, now we see they all are actually same radical. Cubed of 2, cubed of 2, cubed of 2. That means, yes, we can combine them. So we keep our cube root of 2, and we do 3 minus 10 is negative 7. Negative 7 plus 1 is negative 6. So answer is negative 6 cube root of 2. Any question? So when you add and subtract, if you don't have the same thing, always think, can you simplify them so that all of them turns into something same but smaller number? Now let's do one example together. Actually, a few examples together. Do you see the same radical with the same radicand? Yes. That means our life is easy. We see exactly same thing twice. So we keep that and we combine the coefficients. The first coefficient is visible, 4. But what's the coefficient for the second one? 1. So what is 4 plus 1? 5. So our answer here is 5 square root of 5. We have, remember, radical is just like a variable. So this is same as 4x plus x. What is 4x plus x? 5x. So this has coefficient 4. This has invisible coefficient 1. That's how we have the coefficient 5. Do you see any like terms in the next example? Any like terms? Six and 7. So how much we get from 6 and 7? 13. Do you see any other like terms? The variable, the radical. Do you see the exact same radicals in both cases? They're exactly same. So we write the exactly same things. And how do you combine their coefficients? How many we have total? 6 of them. Because we have 5 plus 1 square root of 5 to the 6. We should be done here, right? But we are not. Why not? We cannot add them because 6 has this radical and doesn't have any radical. We cannot combine them, we cannot add them, but we have to do something else. We cannot cancel the 6 with the 6 because this 6 is a power and this 6 is a coefficient. We're going to cancel something. Square root means what? What is our denominator? Is 6 divisible by 2? So see, we can cancel the radical. We get 6 y to the 6 divided by 2. That gives us 13 plus 6 y cubed. So it simplified the radical. Anytime a radical is simplificable, always simplify. If it's not simplificable, you'll leave it alone. Any question? Now comes the example we did. I mean, we saw similar questions before. Do you see same type of radical? We see square root, radical is same, the index is same, but do you see the same radicand, same inside? So you cannot combine them unless we can rewrite 28 in terms of 7. 7 is not reducible, right? It's the prime number, we cannot reduce that. But can we split our 28 into 2 pieces? One is 7 and one is something else, 4. That means we have square root of 4 and square root of 7. What is square root of 4? 2. And square root of 7, you have no idea. So we bring this down. 4 square root of 7. We bring this down, minus 3. Now, between 3 and 2, there is a multiplication symbol. Because between 3 and the square root of 28, there's invisible multiplication there. So we have 4 square root of 7 minus what? 6 square root of 7. Now, do you have the same radical with the same radicand? Yep. So can we add their coefficients? What do you have? 4 minus 6? Negative 2 square root of 7. And these are final answer question. One of them you'll definitely see in the final answer. Before you go, try this by yourself. Then it will be done. I mean, you don't have to try by yourself. You can have a conversation with your neighbors. We have 4 times square root of 18 minus 6 times square root of 8 plus 3 times square root of 2. At the first glance, all of them seem different. So on Tuesday, we are going to do a few more examples of addition, subtraction. Then we are going to multiply and then divide. Yeah, I think we can do division in our next class also. No. And if you want to practice with more question, practice combine your you have to combine your what are minus what's how boys have to what's the symbol what's the symbol we have what is happening. So before you even watch on that, I just want to know so for your three we are on the point and sure so much thank you. So this is zero 17 okay, 92 and 92. So break them down and see if they count. Yes. Okay, number that you have started. 90%. Any more questions?
Yes.
Yeah, the answer for the first one is 3 square root 2, and answer for the second one is negative 19 square root of 5. Any more questions? Guys, have a good weekend. See you all next. Don't forget to do the homework on 10.1 and 3, and also the quiz.